Hello students, pleasant greetings to you all. Welcome back again to another video review lesson from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and of course primarily this channel helps students that are under the examination body of Caribbean Examination Council, that is CSEC, CCSLC, SEA, and various forms of Caribbean exams, college courses, so on and so forth. Now, particularly this review here is as it relates to a most recently conducted exam that I had constructed. It is in fact the final term quiz for a group of students currently being prepared for the 2023-2024 CSEC examination. As we are approaching the end of the first term of that particular year, the following topics that are being demonstrated in this particular quiz paper here are what we have covered in its entirety over the course of the last 2.5 months. So of course, we're going to be sharing the solutions to the questions. I would have already marked the paper for the students who have entered into this exam. The results were not as satisfactory as I would have liked them to be. Hence, therefore, this is all the more reason why this video is going to be important, not only for the students who were successful, but more so for the students who were pretty much unsuccessful in terms of the concept application. So hopefully you guys are going to be able to watch in full and get the necessary corrections, get the necessary clarity, and remove any ambiguity that you guys may have as it relates to the concept. So of course, if this is the first time here on the channel, of course do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments, video requests, let me know your thoughts. If the videos are helpful, what can I do to make them better? And of course, any problem topics that you may have, I'll be more than happy to provide you with a tutorial video that will give you the best advantage to moving forward and becoming a more efficient student. Right, please do not forget to hit the like button. It does help the channel to grow. It gets me on the algorithm, and of course many more students will be able to benefit from these types of content. All right, so let's jump right into the lesson. Be sure to check the description box below. You are going to find a wide variety of information about the teaching services that I offer. Wherever you are, I'll be able to assist you in any level math that you desire. All right, so without further ado, let's jump right into the lesson. Here we go. Now, for this particular review session here, we're looking at a wide variety of topics, and I think that this was a very well-rounded topic, well-rounded paper. It touched every little area that there is, with the exception that there was no ratio and proportion for this topic, for this paper, but that was the only thing that was left off. This topic was well-rounded, and it allowed the students to tap into all areas of the concepts that were taught. So let us see if the students did themselves justice. The first question on screen here, traditionally, of course, is going to be a fraction and or a decimal and approximation question. And of course, we are allowed to use calculators, and we must show all working where necessary. All right. So here we are asked to evaluate the following, that is 3 3/4 minus 2 1/3, all divided by 1 and 1 2/3, all squared. So with this particular problem, the best advice that I've given all my students here is, upon starting this question, number one, you want to convert any and all mixed fractions to an improper fraction. So here we have is 4 multiplied by 3 here is, say, 12. 12 plus 3 is in fact 15 over 4. Take away, say, 2 3s or 3 2s is 6 plus 1 is 7 over 3. All divided by, say here, 3 1s 3 plus 2 is 5 over 3, all squared. We, of course, I particularly like to give my problems a name, or different sections of my problems a name. So I like to name the top part A and the bottom part B. And so from here, I'll be able to easily work out my question in sections. So here is part A. I'm going to rewrite 15 over 4. and that's going to be subtracting 7 over 3. When we are adding or subtracting fractions, we are going to find the LCM, which in this case here is 12. 4 3s is 12. So 4 into 12 goes 3 times. We multiply the top by 3. And 3 into 12 goes 4 times. We're going to multiply the top here by, say here, 4. So then 3 times 15, that's 45. And 4 times 7, that is 28. So mathematically this works out then to be 17 over 12, and that is the answer then for the A section of the problem. Let's hold on to that answer for now. We're then going to move on to the B section here, where in fact we don't have much to work out, but we just need to do square the numerator and the denominator. So here we have 5 squared is 25 and 3 squared is 9, and that there provides us with the result of, say here, 25 over 9. Now we're going to be using the answer that we get for the top, which in this case is 17 over 12, and we're going to be dividing this then by the answer that we got for the bottom, 25 over 9. Now the rules for division is that we're going to invert the last fraction, that is in fact the divisor, so that's 17 over 12, and we're going to change the division sign to multiplication while inverting the divisor. So this becomes 9 over 25. In this stage here, because we are multiplying fractions, we are looking to reduce the quantities by using a common factor. Now nothing can go into 17 and 25, but it seems as if then, say here, 3 can go into 9 3 times and 3 can go into 12 4 times. So we therefore be left with a result of 17 times 3 is 51 and 4 times 25 is 100. That provides us with the complete result for question number 1. All right, we're then going to proceed to the next question, which is a decimal and approximation question, and this requires us to find the square root of 12.452, and we're going to be adding that to the result of 3.4 divided by 0.84 squared. Now this requires us to use the law of PEMDAS, and like I said in the last upload, the last tri-weekly exam review, you would have seen here where I stated that the best approach to this is to write down the PEMDAS mnemonic, and you want to check off what and what is a part of this problem. Do we have any parentheses? No, we do not. Do we have any exponents? We do. We have an exponent here, and we also have an exponent here. A lot of persons don't know that a root sign is an exponent. Well, in fact, a root sign is actually a fractional exponent. So the first thing that we want to do in this problem here, if you're taking it step by step, is to get rid of the square root and the square. So this would have been that the square root of, say here, let me grab my calculator. So the square root of 12.452 works out to be 3.528. We could do 3.5287. all right, and we're going to be adding that to 3.4 divided by, say here, 0.84 squared. That is 0.7056. all right. And of course I did find a couple students trying to add before they divide. That's breaking the rule of PEMDAS. You will notice next that multiplication is our next operation. There is no multiplication available, so we're going to be moving to division next. And so obviously then the only thing to divide here is to rewrite our 3.5287 and then add that to the division or the quotient of 3.4 divided by 0.7056. So 3.4 divided by 0.7056. That gives us 4.8185. all right, it could be 86 as a rounded off answer. I particularly like to work with 3 or 4 decimal places, so that in the end when I get my answer, they may ask me to round off to 1 decimal place, 2 significant figures, standard form. So I want to make sure that I have enough digits for my rounding off in that case. So then when I go ahead then and I add, say here, 3.5 287 to 4.8186, I end up with a result here of 8.3473 rounded off, so it's approximately equal to that. All right, then you'll realize here that most times when you get a decimal problem, they usually ask you for some sort of rounding off, and you'll see here that they say that we should correct our answer to 2 decimal place and also write the answer in standard form. So you're going to find here that to 2 decimal places, then to round this number off to 2 decimal places, we're looking to draw our vertical line in between the 4 and the 7, because the 3 and the 4 would have been the first 2 decimal places. We are then going to check the digit that comes after, and that is in fact 7. So if 7 is greater than 5, we're going to increase the 4 to 5. So we're going to end up with a result then of 8.35. All right, so that is rounded off to 2 decimal places. All right, so let's write 2 dp here. They're asking us then to round off, say, 8.3473 to standard form. Now, based on the review that I would have done on my older channel and any experience that you may have as it relates to standard form, you'll know that standard form is a number where the a value is in between 1 and 10. So it has to be greater than or equal to 1, but at the same time it has to be less than or equal to 10. So right now, as it is, usually given a number, we'd have to move our point into either the left or the right. Now in this case, we don't need to move our point because our point is exactly where we want it to be. So therefore then, since we're not going to be moving the point, it's going to remain as 8.3473 multiplied by 10. Standard form has a base 10. Since we didn't move, it's going to become 0. All right, and that is the answer in standard form. Right? And that would have given you a nice total there of 4 marks. 2 for the calculation, 1 for the DP, and 1 for the standard form. All right, so that takes care of the first 2 questions. That's exactly what you needed to do, students, to attain a total of, say here, 7 marks. We're then going to move on to, say here, question 2. And so in question 2 here, what we're looking at is in fact a variation question. And I find that over the course of my last 3 uploads, tri-weekly exam 1, tri-weekly exam 2, tri-weekly exam 3, monthly exam 1, monthly exam 2, and monthly exam 3, since I started the topic of variation, I've had less than 50% of my students mastering this topic. So I keep bringing it back, hoping that they are going to be watching the tutorials and they're going to be taking note of the common mistake that they make. And so as I look at this question and as I remembered marking the paper, I find that a lot of students failed to not only recognize the type of variation that they're dealing with, but they also consistently forget that there is a relationship change between the variable. What do I mean by that? The very first thing that you guys want to do when it comes to once you recognize that this is a variation question, you need to check and verify which one of the variation is it. Is it direct or is it inverse variation? Well, the question says here that given that the hours H taken to reach work varies inversely. So it varies inversely. Let's take care of that part first. The very first thing that we want to think about here in this question is what is the standard variation, inverse variation formula. And my students are very accustomed to the fact that the standard variation formula is in fact y equal k divided by x. And that is in fact if we are using the variables y and x. Now of course we're going to have to reconvert this formula here, because not only are we not using y and x, we are in fact using, say here, the hours, which is h, and the distance, which is d. So therefore we have to create a relationship between h and d, And we must not forget the constant of proportion or the constant of variation. So here we're looking at the fact that h, which is the time taken to travel a certain amount of distance, is inversely proportional, or varies inversely, as the square root of the distance. And that's where I catch most of my students most of the time. I catch most of my students most of the time where they often overlook. I'm not so certain if they are reading the actual question or they're just picking out the parts that they understand. Oftentimes I throw this little part in here, square root of the distance, or the square of the distance, or the cube of the distance, and only about 25% or less of the students that I teach, or students that have encountered this topic, they oftentimes overlook the change in the relationship between the variables. So for the guys who may have gotten this incorrect, this is where you would have went wrong. You forgot to write the square root of the distance. Now, provided that you are successful, then the first question says that you should write an equation in terms of h and d for the relationship above, which we have already done. You can see here that there's a relationship created right here between h and d, as well as the constant of variation. Please note that many times over I've said to you guys that you are not going to hear the examiner instruct you to write down the value of k. K is a must find. All right, so that gives you a nice 1 mark there, just writing down that relationship. Now, as I have advised time and time again, as you proceed through a variation question, you need to rewrite your formula for every single time that you are going to work a particular problem. So here I've written down my formula: h is equal to k divided by the square root of d. Let's have a look then at what the first question is requesting of us here. Well, the second question, in fact, it says if a man takes 4 hours to travel 180 kilometers, so right here we are given the time and we are given the distance, we are to therefore then determine how long it would take to travel 85. But we are not allowed to, well, we are not going to be able to calculate how long it takes to travel 85 kilometers if we do not know the constant of variation or the constant of proportion. So in this case then, we're going to be using the time 4 and the distance 80 to calculate the value of k. So then what are we looking at then is, in fact, that the hours travel here is 4, and that's going to be equal then to the constant of proportion, which we don't know, divided by the square root of the distance, which is 180. So with that evaluation then, what we're looking at then is, in fact, say here 4 is equal to k divided by the square root of 180 is 13.42 or 13.416. I'm going to just use 13.42 rounded off. All right, so therefore then the constant of proportion k then is equal to, once the unknown is at the top, we are simply going to cross multiply. So therefore then what we're looking at then is, in fact, k is equal to 4 multiplied by 13.42. And if we run that on our calculator, we're going to get an answer here that k is equal to, that's 13.42 multiplied by 4. 13.42 multiplied by 4. We get 53.68. And that there gives us a nice mark, gives us a nice total of 2 marks. Even though the question didn't ask for us to find k, k is the important variable that we need to find in order to find whatever other variables they're asking us to find. We once again are going to go ahead and rewrite our formula. H is equal to k divided by the square root of d, and they did ask us for the, let me see here, they asked us that how long would it take to travel 85 kilometers. So we know then right away that we're looking for h again, and in this case here k is now 53.68, and that's going to be divided by the square root of the distance, which is 85. So let's hop on our calculators here, and we're going to be finding the square root of 85. And so therefore then what we're looking at is hours is equal to 53.68 divided then by 9.21. So this works out nicely to become 53.68 divided by 9.21. We get a approximate hour here of 5.8 hours. We could say if some of you guys wrote, say here, approximately equal to 6, I would have accepted that. But the accurate answer here is 5.8 hours. All right? Perfectly done there. Next, we're going to rewrite our formula once more because there is more questions to be answered. So h is equal to k divided by, say here, the square root of d. And so therefore then, let's look at the question. It says here, how far would you be able to travel in 10.5 hours? So now in this question here, we are given the amount of hours to be traveled. So once again then, now we're given 10.5 hours. So this implies that 10.5 is going to be equal to the constant of proportion, which is 53.68, divided by the unknown distance here. Now when the unknown variable is at the denominator, we're going to do a swap. So that becomes the square root of d is equal to then 53.68 divided then by 10.5. And this is something that my students and I have done numerous times. And there's also a full tutorial on my channel. A link will be in the description to the playlist, as well as it should pop up here in the cards at some point. That brings you directly to that full tutorial video on direct variation as well as indirect variation. So do definitely check that out if you want a bit more foundation knowledge on this topic. So 53.68 divided by 10.5, and that gives us, say here, that the square root of d is equal to 5.11. Now in order for us to isolate d, because it is covered by the square root, we are then going to square both sides. So that's 5.11 squared. And then we get an approximate distance here of 26.14 kilometers. Is it kilometers? Are we working with kilometers? Yes, we are. So 26.14 kilometers. And that is the variation question. That is the question. That is the solution to that particular problem. I do really hope that along with my full tutorial video on direct and indirect variation, as well as this particular review, as well as the other tri-weekly exam reviews involving variation and indirect variation, you should be able to finally master this particular concept. All right then, we're going to be moving on to the next question then. So this particular question here, as I had mentioned, and I'm not sure if I had mentioned it in the beginning, there are two groups of students that I am currently teaching for the 2023-2024 exam, and some groups of students would have already done this topic, while some students have not yet done this topic. So therefore then, for the students who would have already completed this topic, here is the solution to the problem. And for the students who have not yet done the topic, you are getting now a premature exposure to what's coming. It's saying here that a company offers loans at a compound interest at a rate of 8% per annum. We are to determine the interest gained if a woman borrows a sum of $500,000 for 2.5 years. So for this particular question then, we need a formula. And the formula for this question then would have easily been that compound interest, all right, is in fact the amount occurring after a certain period of time is equal to the amount that you borrow or invest, which is known as your principal. That will be multiplied by 1 plus the rate of interest divided by 100 multiplied by the power of, or raised to the power of, the time taken for that investment or that loan. So in this case here, we're looking for A, and the amount that was invested was $500,000. We're then going to multiply that by 1 plus the rate, which is 8%, divided by 100. And it was invested. Well, I'm not sure if it was an investment or was it a loan. Let's double check on that. It was in fact loans being offered. So it was a case where she borrowed a sum of 500,000. So this particular example here is a loan. And it was for 2.5 years. So that's 2.5. Now, all of this here requires the rule of PEMDAS again, where we're going to be working what is in the parentheses first. Again, it always helps if you're a fundamental student to write down the mnemonic PEMDAS and double check on what needs to be done here. Now, there is a parenthesis, so I'm going to work that part first. So the parenthesis here is in fact that A is equal to 500,000. And that will be multiplied by 1 plus, I'm going to divide because I'm doing what is in the bracket, but I have to divide before I add. So that's 8 divided by 100, which is 0.08, raised to the power of 3. Pardon me, raised to the power of 2.5. I'm still not done with the parenthesis, so I'm going to go ahead then, and I'm going to say A is equal to 500,000 multiplied by 1.08 raised to the power of 2.5. Now the parenthesis is completed. Are there any exponent? Yes, there is. There's an exponent. So we're going to hop on our calculator, and 1.08 raised to the power of 2.5. So that's 1.08 raised to the power of 2.5. We get an answer here that A is equal to 500,000 multiplied by 1.2121. And if you go ahead and multiply that by 500,000, then you're going to find here that the amount occurring after 2.5 years is $606,079.22 rounded off. All right. So that's the amount that would have been in the account. That would have been the amount that would have been owing based on what this woman had borrowed. Now the question did in fact, and we can just pull that back up on screen, the question did in fact ask us for the interest that was gained. And I'm assuming that it's the interest gained by the company. It could have stated that determine the interest that was charged either ways. So in order for us to calculate the interest then, what we're looking at then is in fact that interest is going to be equal to the amount that is currently occurring minus what was borrowed. So the interest here is equal to 606,000 and 79.22 minus the 500,000. So therefore the interest that would have been charged, or the interest that would have been gained by the company, is 106,079.22. Right? Beautiful. So that is how you'd evaluate that particular problem. It's a formula based question, so if you do not know your formula, you're then going to find that it's going to be a challenge in doing this evaluation. All right, good job. For those who got it right, good job. We're then going to go on to looking at, say here, this part 2b, which is a foreign exchange question. And I did in fact give my students two very basic rules when it comes to this particular problem here. What we're looking at, and the key here, is understanding when it is that we are converting from a larger unit to a smaller unit. Now you're going to find that in order for us to recognize which unit is small or large, the unit that has more value, or if it takes more of one currency to make a small amount of the other currency, then it's safe to say that the US currency is in fact bigger than the Jamaican currency. So Jamaican currency is smaller. And it's a similar way here where the US currency, it takes 64 TT dollars to make a single US dollar. So once again, the US is also larger than the TT currency. And if you were to even make a deeper comparison here, you'd recognize that the TT currency is actually larger than the Jamaican currency because it takes more Jamaican money to make a US dollar than it takes a Trinidad and Tobago dollar. All right, and remember guys, this is just a structured question. This is not something that is currently accurate. I think it's a little bit higher than that as we speak. Now the simple rule is this, and we're going to write this here hopefully for students going forward. If you happen to be converting from a larger unit to a smaller unit, we are going to say here multiply. And of course, if you're doing the opposite, smaller, say here to larger, you're going to simply divide. That's all you need to know to solve this type of question. Now, the very first thing here that is asked, and let's look at the exchange rate once more. US $1 is equal to Jamaican $145.62. And the US $1 is equal to Trinidad and Tobago dollars 64.36. Our job here is to determine how much TT dollars would be equivalent to Jamaican 135,000. So to answer this question, the first thing that we have to look at is that is there a direct exchange link between TT and Jamaican money? Well, according to this question, there is not. So this means that I would have to convert the Jamaican money to the US currency and then convert the US currency back to TT currency. So to answer this question then, we're looking at converting JA 135,000. First, it goes to the US currency. So what would we do here? We are obviously converting from a smaller unit, as we have established here, small already, to large. So we're going to small to large is to divide. So we're simply going to divide the 135,000 here by the value of $1 US in Jamaica. So 135,000 divided by 145.62 according to this question. And so you're going to find that the conversion to US here, 135,000 divided by 145.62, you're going to find that this is equal to US $927.07. Now that that is the equivalent of the 135,000, we're then going to convert that to Trinidad and Tobago dollars. And we already know here that $1 US is equal to TT 64.36. So since as 1 US is equal to 64.36, then 927 of those is going to be equal to, say here, 927.07 multiplied then by 64.36, because we're converting from a large to a small. Then you're going to find here that this is going to be equal to, say here, 59,666.25, and that is the value of the $135,000 Jamaican to TT currency. All right, very good. And you'll see that there is not a lot of math that was really done. It's just understanding whether you're converting from large to small and small to large. Fine, then we're going to be moving on to the next question, which is then, how much change would someone receive, or sorry, how much change would someone have left in Jamaica if they spent 23,500 in TT? So assuming that the money, the 23,500 was spent from what we currently have here, that's the only logical assumption that we can make here. We are therefore going to have to find out how much is left in TT after 23,500 was spent. So we are then therefore looking at the fact that 59,666.25 subtract 23,500 will therefore give us the balance that is left in TT. So 59,666.25 take away 23,500, you're going to find that 36,166.25 is what's left over in TT currency, assuming that the money was spent in Trinidad and Tobago. So this is what we have left in TT, but the question is then asking us for how much change or how much would be left in JA. So now we have to do another conversion, because now we have to convert from TT back to JA. But just like the first step here, there's not a direct link between TT and JA. So then we're going to have to convert this TT here, TT 36,166.25 back to JA, back to US, first of all. And so by doing that, we're going to have to divide by the value of 1 US in TT. So that's going to be 36,166.25 divided by 64.36. And we're going to end up with an amount of $561.94. 94 cents, 561.94, and that is currently in US. And then therefore now finally then we have to convert this back to say here Jamaican. So now we're converting once again from a large to a small. So US 561.94 back to JA is going to be equal to 561.94 multiplied by the value of 1 US in JA, which is 145 point say here 62.62. So let's hop on the calculator then, 145.62, and you're going to find here that we have a total leftover of 81,829.23 in Jamaica. All right. So even though I took some time to really go through the problem, I wanted this to be very elaborate and very clear, so that going forward in the event that you see a problem like this, you know exactly the thought process that takes you through to getting to this answer. All right, so that would have given you a nice solid 5 marks, or 4 or 5 marks maybe. All right, so hopefully you guys got onto that particular problem then. We're gonna then move on to question 3. All right, and we are about 40 minutes into the session, so we should be over by, say, in another hour and a half. So that's about an hour and a half we should be able to complete this paper, but let's take our time and make sure that we get everything right here. Now the next question here says that we should simplify the following expressions, and let me just go to a page. I think I may have written it down already. We are to simplify the following expressions, and that is in fact, say here, 4a squared x to the minus 5 multiplied by 5a to the minus 5 x to the minus 1 divided by 10a x to the 7. All right. And so for this particular question then, what I find after marking the papers and what I find consistently is that students are fundamentally struggling, but they're still trying to do mental math. This particular topic here highlights the importance of indices, law 1 and 2. When you have to multiply and add, you add powers, divide, you subtract powers. It also brings out the ability for you to add integers without a calculator. And it also highlights the importance of you learning how to organize and group according to common bases. I find that these three areas are where students mostly struggle with. Now, what I find is that a few students did in fact took the correct approach by saying here, say 4 multiplied by, say here, 5 divided by 10. But I'm not sure, but quite a few students didn't really organize properly. And like I said, this particular method that I'm using here, where I say a squared multiplied by a to the minus 5 divided by, say here, a, there's no power, well, there's no visible power, so the power understood is a 1. And that's going to be attached with x to the minus 5 multiplied by, say here, x to the minus 1 divided by here, say here, x to the 7. What I find here is that students, one of two things: either they do not want to write it out like this, or they are mentally trying to do the problem. Or what usually happens is that there are going to be sometimes sign clashes, and that can significantly change the result that you get in terms of the powers. I do strongly recommend that if you're a fundamental student and you're rebuilding your math skill, you want to lay out the problem like this. Otherwise, you can simply do like what I would do as an advanced student or as an instructor. I would mentally do it because, of course, I am very much well-rounded when it comes to adding integers. But, of course, approach the question this way. 4 times 5 is 20, and 20 divided by 10 is, in fact, 2. And of course the bases are the same, so I'm going to just rewrite my a. Then I'm going to try to figure out whether or not I should add the powers as opposed to subtracting the powers. Now the first two a's are being multiplied, and that means I'm going to be adding the power of the first a to the power of the second a. But then the last two a's are dividing each other, so this is the negative 5. I'm going to be subtracting, say here, that power of 1 because I'm dividing. Then I move on to the x here, which is 1. And the first two x's, oh pardon me, that's not 1, it's actually negative 5. I do apologize for that. So the first x here is negative 5. And because the first two x's are being multiplied, I'm going to be adding the negative 1. And that's where the sign clash comes in. Many students miss that part. And then the last x is that I'm dividing, so I'm going to be subtracting 7. And when you do it like this, you're giving yourself the maximum opportunity to get the question correct. This is a 3 marks question, so you want to be very detailed with your answer. Moving next then on to the fact that this is 2a. At this stage, if you want to, you can just simply go right ahead and type your powers on your calculator, or you can use the textbook method or the O&half method. For me, I'm just going to be using the traditional method of mental math. So this is, I have 2 and I owe 5. I pay the 2 that I have and I'll still owe 3. Now that I owe 3 and I owe another 1 on that 3, I now end up owing 4. Again, you can always do it that way, or you can just type it into the calculator exactly as you see it, and it should give you the right answer. This is x then. I owe 5 and I add another thing that I owe here. I owe another 1 on that, so I now owe 6. Now since I now owe 6 and I now owe another 7 on that 6, it ends up meaning that I'm now owing 13. And so therefore this becomes my final result. So if you're not approaching the question this way, then that's what you're going to find, that you often get the questions incorrect. I do strongly recommend that in now and in the future, as we go deeper and deeper into the course, you're going to find more and more questions that will require more and more steps and more strategy. So you want to give yourself the best chance of getting these types of questions correct. All right? So hopefully you've finally gotten over the concept of laws 1 and 2 when it comes to indices mixed with algebra. Let's move on then to this particular question here. And this wasn't a challenging question. I actually, in fact, find quite a bit of the students being successful. I think probably about 40 to 45% of the students getting this question correct. But still, I find that students are struggling with grouping the like terms. So for this one here, what we're looking at then is in fact 4a squared minus, we're looking for the other term that is squared. We're grouping like terms. So this in fact is 3a squared. There's no more squared term with the a. There's an a squared here, but it's attached to an x squared, so that's not the same thing here. We're going to be looking next for all the ax's. So you have minus 2ax here, and then we have positive 5ax here. And then of course we have this odd term here, a squared b squared. Now that all the terms in the expression are now grouped properly, we can therefore subtract the terms that are alike. So this becomes 4 minus 3, and that becomes 1. If you want to write the 1, you can, but then we have to rewrite, say here, the base, a squared. In algebra, we don't usually write 1, we just simply write the base. And again, I still see that students are really struggling with integers. At this stage, I find that some students are still adding 2 to 5 and saying that the answer is -7. It is full time that students now and in the future understand that the sign that is in front of a number belongs to the number. So therefore, this is, as opposed to being 2, it is -2, which means that you owe 2, and here you have 5. Once you pay what you owe, you then have 3 left over, so that's 3ax. Then that odd term here, nothing can be added or subtracted from that, so that becomes a squared x squared. I might have made an error here. It's not a squared b squared, is a squared x squared. My bad here. So that's my final result. Then my final result is in fact a squared plus 3ax plus a squared plus a squared x squared. Right? And that's it for that question. The next one here is the application of the distribution law. And again, I find, and I do have some of my students that are actually watching this video, it was advised even in the tutorial that I did, which I will leave a link in the description that brings you to the playlist on my distributive law videos. I find that some students are actually distributing over the term that immediately precedes the bracket, and this is encouraged, that you do not distribute when you're not immediately in front of the bracket. As opposed to distributing the 4y, we would instead distribute the -3x. And for the students who have gotten this question incorrect, you're clearly then seeing exactly why you got the question incorrect. So this 4y does not need to be touched at the moment, so it comes back down, and then we're going to be distributing the -3x. So -3 times 4 is -12 along with the x, and then the minus here multiplies the minus inside, becomes a plus. 3 5s is 15, and x times y is xy. Say then we're looking at 5 times x is 5x, and 5 times y is 5y, minus 8xy. Now it's time to once again group like terms. Since as the y is at the front, let's start by looking for all the possible terms that has a y. We have 4y. Let's scour through the problem. There's an xy here that's not alike, so let's look. Okay, so there's a 5y here. Then what we have next is in fact the x's, so we have -12x, and we're looking for all the possible x's, that's plus 5x here. Then we're looking for all the xy, so that's plus 15xy minus 8xy. Now that everything is organized according to like terms, then we can go ahead and proceed to add what can be added. So 4y plus 5y is 9y. And before we quickly bring down our sign, let's check to see what happens here. We owe 12 and we have 5. If we pay the 5 that we have, we end up owing, say here, 7x. And then, of course, 15xy minus 8xy is in fact 7xy. And that there is our final answer. Now, again, the order in which you choose to group your like terms doesn't matter. So if you wanted to group the x's first, then the y's, then the xy's, or the xy's, then the y's, then the x, or the xy's, then the x's, then the y's, it doesn't matter, as long as you know that you're not allowed to add or subtract on like terms. All right? So that clears up what you should have done or where you may have went wrong. Hopefully you can then use this particular lesson here so that when you see this again in the future, you are going to be able to be more efficient and more accurate when it comes to producing the result. All right? We're then going to be moving on to another phase of the question here where we were asked to, in fact, express as a single fraction and also to factorize. Now, I may have made an error in terms of the instructions. I'm hoping that my students weren't thrown off. What I really should have said was that we should express these two as a single fraction and factorize this one. I think I may have corrected them in the exam. I'm not certain. So hopefully that is not an excuse as to why they may have gotten it incorrect. I'm hoping that they would have seen that the addition and the division there would have been an example of single fraction. And then, of course, we know that we cannot really subtract these two terms. So it would have meant that that was the only question to factorize. Hopefully that you guys picked up on that little error there in terms of my instruction. But let's get to the question then. The most important thing is that we understand how to approach the question. What I did also find is that minimal amount of students actually got close to the answer. I think if I remember correctly, maybe 2 or 3 students would have gotten this question right. And I set this question up because I wanted to see if the students would have picked up on the double bracket expansion. And that is the binomial expansion, which a link is in the description, and also it should be popping up here in the cards. That takes you to a video of how to expand what you're about to see. So the very first thing here that we need to do, that to express as a single fraction, we obviously have to find the LCM. And it's not like the traditional arithmetic fractions where you can clearly see that the denominators are numerical values. One is a binomial expression and one is a numerical value. So when that happens, your LCM becomes the product of both. So we write the LCM like that. Now, surprisingly, many of my students did not really see the fact that the x minus 2 goes into the LCM here, leaving us with 7. So that's 7 multiplied by 8. In other words, then the x minus 2 cancels the x minus 2, leaving us with 7. And so the 7 will multiply the numerator at top. So we'll just bring that down on the line. And then the 7 cancels the 7, leaving us with x minus 2. So now that the x minus 2 is a binomial expression, we remember that we have to write our binomial expression into a bracket. So this brings us x minus 2 in bracket multiplied by the top, which is also a binomial, which also must be written in bracket. So I was really hoping that the students caught on to the fact that this is a double bracket expansion. A couple students picked up on it and they were successful, while majority of the students didn't even get to this part where they wrote down the correct thing on the line. So that would have thrown you off completely. Nevertheless, 7 times 8 here is in fact 56 plus, and we're going to be distributing the bracket here. First with first, first with second, second with first, second with second. Many students struggle when it comes to transferring and applying concepts learned in box 1 That is a requirement in box 2. Most students are accustomed to getting the question in phases, in a vacuum. But in an exam setting, you're going to be required to transfer knowledge learned last week to knowledge that you're going to be utilizing next week. X times 3x is in fact 3x squared. X times minus 1 is minus x. Minus 2 times 3x is minus 6x. And minus 2 multiplied by minus 1 is in fact positive 2. And this is then all over 7 open bracket x minus 2. Now it's once again time for us to say here group like terms. So we know that there's no other squares to be grouped with the 3x squared, so that comes back down here as being, say here, 3x squared. Then we have the exit, so that's minus x minus 6x. For an advanced student, you could go ahead and write down already minus 7. And again, 2 and 56, they are both numerical values, so that's 56 plus 2. And that is then all over 7 open bracket x minus 2. I kind of prefer working my problem in parts. It really gives me the confidence as I go on. It does open up the possibility for me to make a mistake, but it also gives me clarity in what I'm doing. I can be able to trace my question backwards in the event that I feel like I made an error. So then my final result here is 3x squared. I owe 1, I owe 1x, and I owe 6x, so I now end up owing 7x. So this is 1, 01, 06, 07. 56 plus 2 is in fact 58. And then that is all over 7 open bracket x minus 2. Again, the order of the numerator doesn't matter as long as you know you cannot add terms that are unlike. All right? And that takes care of that 3 marks question there. This was also a very interesting question and very surprising. I tried to make the question to look a little bit complicated so that I could test the ability for my students to cancel and pay close attention. This question requires you to detailedly write down your terms. It also brings back the knowledge of it also brings back the knowledge of multiplying and dividing fractions. Now what I find that, well, in my findings and my review of marking the papers for the students, I find that they got a bit flustered with the amount of different variables and powers that were presented. What you guys need to do when you get questions like this is to first take it in steps by looking at what needs to change. And so we have 2 operations that have similar rules, with the exception of division that requires us to invert the divisor. So let's start off here by writing down the 3L m4, m to the 4 divided by 14a squared x to the 4th. Because we are dividing a fraction, we know that we have to change the division sign to multiplication. Then we're going to invert the last fraction, the fraction that comes after the division sign. So the 18a to the 4th x goes at the top, and the 9l squared m3 goes at the bottom. Then we proceed to multiply once again by 12a 5 x4 all over 21 L squared M. Now what you have to do here, guys, is carefully and slowly cancel out in order. I like cancel outing numbers, then I cancel out letters by letters. So I'm going to start off with the numbers here. I'm going to say here 3 into itself 1 time, and 3 into 9 3. I can go ahead, then I can say 2 into 14 7. And 2 into 18, 9. I'm cancelling according to what I'm seeing. There are different methods to cancel out. Here, I could cancel 3 with 12 and 3 with 21. But my first side here is that I can cancel the 3 here and the 12 here. That gives me 4. Then I also saw that I could cancel 3 into 9 3 times and 3 into 21 7. That is how I saw the cancellation. You can cancel a different way as well, but we should end up with the same answer. Let's move on then to look at if we can cancel any L's. So there's an L here, and there's 2 L's down here, so there's only 1 L is left down here. Alright, let's look at the M's. We have, say here, M4 and M3. Well, the 3 M's down here are gone, leaving only a single M at the top here. Alright, so I'm moving right through. I'm continuing here. I'm looking for the A's then. So there's A4 here and A squared here. These 2 A's at the bottom are gone, so I'm then left with A squared at the top. X4 is down here. X is up here. This X is gone, so it leaves X3 at the bottom down here. And I'm moving right over here with this A. Let me see if I have any A's at the bottom left down here. There's no A's at the bottom, so I'm going to leave that A5 alone. And then there's an A square here, but we know that we can't cancel numerator with numerator. It has to be numerator with denominator. Let's see if there's any more X's at the bottom. There is in fact 4 X's here in red, and there's 3 X's in purple down here. So these 3 X's are now finally gone, leaving me with only but a single X at the top here. And then I'm looking down at the bottom here. I have a L squared. Let's look at the top if there's any more L's at the top. There is no L's at the top. There's no L's at the top. There's an L at the bottom, but it can't cancel, so I leave that L alone. And there's an M here, and there's an M in purple up here. So both M's are gone. And it seems as if that is my final cancellation. Now, by writing down my answer, I will also recognize if there was any missing cancellation. So let's look at the numbers first. At the top, we have 1, 1, we have a 3, and we have a 4. So 3 4s is 12. All right, so the numbers are gone at the top. Let's look at the letters. There's no L's left at the top. Okay, there's no M's left at the top either. There is an A squared here, and there's an A5 here, so that is A7. A squared and A5 here. And then so here that we have this single X right here. So that's X here. All over, let's look at the numbers for the bottom. 7, and we have a 1 and we have a 7, so 7 times 7 is 49. There's no A's left at the bottom, obviously, and there's no X's left at the bottom, obviously. There's an L here, and there's an L2 here, so that's an L3 in total. And then that's just about it. There is no M's at the bottom left. So by carefully doing this very neat cancellation, you easily attain your result if you take your time and do proper cancellation and focus when you're cancelling. All right, so that takes us to the end of that particular problem then. Now this is the last question here, where it was a requirement for us to factorize. And again, this was a topic that would have been done maybe a day or a day and a half. I'm going to say approximately a day and a half before the actual exam. And so factorizing this expression, I also found that less than 50% of the students got this question correct. And as discussed in the class, that the verb factorize means that we're looking for a common term that is exactly divisible into both expressions. The factor can be numerical, the factor can be an algebraic expression, or a combination of a numerical value and an algebraic expression. So in this case here, the question is what number, or what's the highest number that can go into 14 and into 21? And it so turns out that the answer is 7. If we look carefully, then we'll recognize that P is also a common factor. But we have a P squared and we have a P cube. And as advised, that the term with the lowest power should be your HCF. X is not common. It is on this term, but it's not on that term. So we cannot bring an X on the outside. Now we proceed to write what is left. That's what I would have told my students. Write what is left, or we just proceed to divide. 7 into 14 goes 2. And the p squared that was here, it's on the outside, so there's obviously no p left on the inside. 7 into 21 goes 3. And p cubed, p squared is on the outside, so only p is left on the inside, along with the x. And that there completes the factorization of that expression. So it was really an easy 2 marks question. A lot of my students would have made a huge mistake. Some of my students would not have even attempted the question. Hopefully that explanation was a bit clear for you. All right. Please look out or review factoring techniques on my channel. I don't currently have a video on my current channel on factoring, but that will be coming up sometime in December. So definitely stay tuned for factoring techniques in say here on the channel. All right, fantastic. So we would have completed the algebraic section of the paper then, and so therefore we're going to be moving on to question 4, which is the measurement aspect of the exam paper. So we're about an hour and 5 minutes, or a little bit over an hour and 5 minutes. Let's see if we can wrap this up in the next half an hour, or the next, say, 55 minutes. Let's see if we can keep this under 2 hours. The diagram below, which I'm going to be pulling up on the screen in a moment, is a fuel container that is in the shape of a cylinder with a conical covering with the dimensions as shown. So by just reading this as an experienced instructor and as an instructor for students that are learning, I often advise my students to read carefully, because most times a clue to what needs to be done lies in the information given here. And so first thing that I see here is the fact that they mentioned that there is a cylinder and there's a conical covering, which means that there's a cone that's involved in this problem. Let's have a look at the diagram. So you'll see here that on the diagram that I'm putting up on screen here, you'll see that this is the diagram that matches the particular question that was just read. Now, for the purpose of this video, I had left out a particular measurement on the exam for one group of my students. And I would have also, I think, missed out giving them a formula, a particular formula for calculating a part of the question in this exam. I would have awarded them the extra marks. Well, I would not have awarded them the extra marks, but I would have actually given them your percentage from a lesser mark as opposed to the maximum. So I had initially left off the 18 centimeters for the slant side here, which is going to be key in answering one part of the question here. Now on this diagram here, you'll see that this is a fuel tank with a cylinder at the base and a conical covering. The height of the conical covering is 4 and the slant side of the covering is 18. The radius, as you can see, that the center of the line here is the point is in the center and it's been drawn to the edge of the circumference. That's 12. And you'll see here we have shaded the top and the bottom part of the cylinder, which is what we refer to as the cross section. Remember that we said in our tutorial video, also in the live classes, that the cross section of the prism is in fact the face of the prism, which can either be at the top and the bottom, the side and the side, or the back and the front, or easily identified as the two identical shapes on the prism. So that's pretty much what we're looking at then. Let's go back to the question then to see what was requested of us here. So what was requested of us here is to first determine the area of the cross section. And so if you do not know the meaning or what is a cross section, you won't be able to actually solve this question. So the cross section here is the part that is actually shaded in this video, but it is also identified as the two identical shapes on the prism, which is a circle and a circle. So therefore the cross section of this particular prism here is in fact a circle, and so the area of a circle is in fact pi r squared, and this is going to be our cross section. So the area of this cross section here is in fact 3.142 multiplied by the radius is in fact 12 squared. Let's hop onto our calculator then. We end up with 3.142 multiplied by 12 squared. 12 squared is in fact 144. So 3.142 multiplied by 144. So the area is equal to then 452.45 square centimeters. And that is the area of the cross section, because the cross section is in fact a circle. We're then going to be looking at solving, then say here, find the volume of the container. Now it is key to understand that the fuel container is not just the cylinder, but it also has a covering. So the container, it is not just the bottom half, and we have to make the assumption that even though it's covered, the fuel tank is going to be filled to the apex of the container. So it's not a case where the fuel is going to be filled up to here and then it's going to stop. It's probably going to go past here all the way up to the apex of the container. So that's the assumption. If you didn't assume that, then it might throw you off. I find that a lot of students were, well, not a lot, but for the students who actually attempted this question, they interpreted the question correctly. I might have needed to mention that the container has to be filled to the apex, but again, I said sometimes you guys have to use a bit of logical reasoning here. So in this case here, we are looking for the volume of the cylinder as well as the volume of the conical covering, because the cone covers the cylinder. So therefore then, let's look at the fact that volume overall is equal to area times height. And so I'm going to just refer to this particular prism here as a composite prism. And why it's called a composite prism? Because it is more than one prism put together that makes the complete diagram that you're looking at. So we're looking at the fact that V is equal to AH. I'm just going to be calling this V1, which represents, say here, the volume of the cylinder down at the bottom. So this is V1 here. And then of course I'm going to be calling up here V2, because this represents the volume of the conical shape or the conical covering. So V1 is equal to, well, in fact, remember that the cross section or the area of the base is a circle, which you'll recognize here that we have already calculated the area of the circle. So this answer here can simply come back down here. And that's what I like about questions like these, because what you're going to find is that when CSEC sets up a question, the answer that is in part A usually helps us to solve part B, and the answer in part A and B comes together usually helps us some way to find or solve part C, and that sequence continues. Part A, B, and C comes together, or aspects of part A, B, and or C will help us to find the answer to part D. So here I don't need to really calculate the area of the base because I've already done that. That is in fact the cross section, and I'm going to times this then by the height of the, say here, the cylinder, which my students would have already known. I didn't write it on the diagram here, but it is in fact 15 centimeter. So therefore then when we go on our calculator here, we end up with, say here, multiply then by 15. So 452.45 multiplied by 15 gives us a volume of the cylinder to be 6,786.72. That is V1. Let's just write that right here. 6,786.72. We now have to proceed to find V2. V2 once again, or V again, is equal to area times height. So the volume, noted here that the volume of a cone is actually the volume of a cylinder divided by 3. So I would have already provided my students with the formula on screen or on the board that volume of cone is equal to pi r squared h divided by 3. But if you notice here that pi r squared h was already calculated here. So pi r squared h but this time the h is different, because the h that we had here was in fact the height of the cylinder, but the height that we're using now is in fact the height of the cone. So we have to do a simple little calculation here. V2 is equal to pi r squared, which we already have to be 442. Let's just write that in a different color ink. So that's 452.45. That's the base area. It's the area of the top here. Multiplied by, instead of times 15, it's going to be times 4. So 452.45 times 4, that's 1,809.8. But remember that it is in fact divided by 3. So it is 1/3 of this. So that then equals to 603.27. So that's 603.27. And that would be the volume of the conical shape at the top. It is 1/3 pi r squared h. So to find the complete volume of the, let's just write that here, it's 603.27. And so to find the full volume of the whole entire prism, it is V1 plus V2. So that's 6,786.72 plus 603.27. And that therefore gives me a volume of 6,786.72 plus 603.27 gives me a total volume of 7,389.99, rounded off approximately, cubic centimeters. This is actually cubic centimeters. This is also cubic centimeters. So that is the volume of the whole entire container, from the base to the apex, from the apex here to the base of the prism. All right, so hopefully you guys finally now understand the thought process that goes into that particular question there. Now the next thing that was requested of us here to answer is in fact to determine the surface area of the prism as well as the total surface area. All right, I did instruct my students that surface area, when I tell them that surface area, or they ask to calculate surface area, it actually means curve surface area. Please note that only the cone and the cylinder contains a curve surface area. All right, so this is the part of the question where I may have not given the students the formula for the curved surface area of a cone. And I had educated myself with this over the course of marking it. I had done some research. I think I may have made an error, and I must be honest with myself. I may have made an error in terms of giving the students the incorrect formula for the curved surface area of a cone. I had instructed them that it is in fact the curved surface area of a cylinder divided by 3, which is completely inaccurate. So I do apologize for that. Hence, I would have corrected myself and awarded the necessary adjustments to the marks for the students. So therefore then, let's get back to what really is. What we're looking at then is that the curved surface area, and let's go back to the question. Let's just verify what we're doing here. We are looking for the curved surface area of the prism as well as the total surface area of the prism. So the curved surface area of the prism is going to be the curved surface area of the cylinder plus the curved surface area of the cone. Please note that the prism you're looking at is two different prisms put together as one. So that's the interpretation behind this question here. So if you go to this page here that we're looking at, you'll recognize that we have two formulas written down here: the volume of the cone, which we already established, and the curved surface area of the cone, which is in fact pi r L. L, which represents the slanted side of the cone. So let us find let us first find the curved surface area of the cone. And that's going to be equal to pi r L. And so pi is 3.142. The radius is in fact 12, and the slanted side, which we had established, is in fact 18, which you're seeing here on screen. Again, for the students who are watching this, you did not, or you were not awarded, well, I did not mark your paper for that section because I would have accidentally left off that particular measurement. All right, so not to worry. So then here we go. It's going to be curved surface area of the cone is going to be 3.142 multiplied by 12 multiplied by 18, and that's going to be equal to 678.72 square centimeters, and that is the area of the curved section of the cone. Let's then look at the curved surface area of the cylinder. And that is in fact going to be 2 pi r h. Because remember that curved surface area, the natural formula for curved surface area, let's just write that down. Students would have already known this. That the curved surface area of any prism really is the perimeter times the height. And that is why we have, say here, the perimeter of the cone is pi r L. All right, the cone is not a complete circle, it's not a complete cylinder, so that is why we have this adjusted formula here. But in fact, the perimeter of a circle is 2 pi r, and the height is in fact 8, so that's going to be 2 multiplied by 3.142 multiplied by 12 multiplied by the height is 4. Oh, the height, pardon me, is 15 because we're doing the cylinder. So let's jump on our calculators. Then we have 2 multiplied by 3.142 multiplied by 12 multiplied by 15. We end up with an answer here of 1131.12 square centimeters. So therefore, the curved surface area of the entire prism, so the C dot S dot A of the prism, is equal to 1131.12 plus 678.72. So then we have 1131.12 plus 678.72. That gives us an answer of 1809 0.84. I think I may have had a student that got this incorrectly, and I may have marked them incorrectly. So hopefully if they see this video or they're watching this tutorial, they may be awarded an extra 2 marks there. All right, so that is in fact the curved surface area of the prism. We were also asked to find the total surface area of the prism, so we must continue then. So the total surface area is in fact equal to the curved surface area plus 2 times the area of the cross section. So then total surface area is in fact the curved surface area, which we just calculated to be 1809.84. And so naturally, if this wasn't a composite prism, we would have to multiply this then by 2a, because if you go back to the prism, you'll realize that the prism itself really only has one cross section. The prism itself put together only has one cross section, which is at the bottom. The cross section at the top here is on the inside, so that therefore would not contribute to the total surface area of the prism. All right, so I must make a correction in that analysis there. When it comes to finding the total surface area of this prism, we are going to in fact find the total surface area of the cylinder, and we're going to then find the total surface area of the cone. That's how we have to approach it, because if we try to look at this from a whole dimension, it's going to appear as if it only has one cross section, but we have to find the total surface area of the prism separately. So therefore then, again, I would have forgotten another formula to give my students, but let's learn. We're learning together. So then it's going to be, say here, the total surface area of individual shapes. So the total surface area of, say, the cone, which can be calculated by the formula pi r squared plus pi r l. So it's going to be the perimeter, or it's going to be the curved surface area. If you notice here that the pi r l here is the actual curved surface area here, and of course it's going to be equal to the base. We know that the cone only has one cross section, which is going to be pi r squared, which is a circle. So we have eliminated that 2 there because it only has one cross section. So it's more or less the same formula here. All right, I guess I really didn't need to give my students this particular formula. Little intuitive thinking here. So pi r squared, let's look at that. We would have already calculated pi r squared. Let's go back to that. The pi r squared, which we would have calculated here, would have already been 452.45. So we can just drop that in right here. 452.45. And the pi r l would have calculated up here to be 678.72. So 678.72. So most of the math was already done for us already. So then we end up with here is 452.45 plus 678.72. And so we'll end up here with 1,000. But we'll end up here with 1,131.16. It's very close to what we had here. It's very close to the actual curved surface area of the cylinder. It's pretty close. Pretty close. All right, so that would have been the total surface area of the cone. Now we need to find the total surface area of the cylinder. All right, So the total surface area of the cylinder is in fact going to be the curved surface area of the cylinder plus 2a, because there's two cross sections on the cylinder. Now we would have already calculated the curved surface area of the cylinder. So the curved surface area of the cylinder, which we have here, is in fact 1131.12. So 1131.12 plus 2 times 452.45, because that is the area of the base. And there's two of them. If you look at the cylinder, there's one at the top and one at the bottom for the cylinder. So then this is 1131.12 plus, take our time, 2 multiplied by 452.45. That's in fact 904.9. So that's therefore equal then to 1131.12. That's 2036.02. Now I would have seen where some of these numbers look a little familiar when I was marking some of my students' papers. So if you guys are watching this video and you would have seen that you have these results and I would have marked it incorrectly, I'll be more than happy to award you the marks. All right, this was in fact a tougher question than I thought it would have been. So I really don't blame my students if they have gotten this part or they would not have gotten maximum marks. But this question was in fact a tricky one and it required you to think a lot. So definitely a tough problem. I'm going to label this problem as a really tough question. All right. Nevertheless, we are learning then. All right. And it's just a matter of just capturing the knowledge and moving forward. All right then. So that therefore gives us so far. So the total surface area of the cylinder is 2036.02, and the total surface area of the cone is 1131.16. So together the total surface area of the whole entire prism is 2036.02 plus 1131.12. 0.16, pardon me. So that gives us a total surface area here of 3167.18. All right, very, very tough question, guys. All right, way tougher than I thought it would have been. So that is it for that particular problem then. All right, so I would recommend that you guys just kind of watch this section over of the video so you can get a comprehensive understanding of the interpretation. All right, I'm actually working this question live. I didn't really think about it or work it out before coming online. I just went right ahead and landed it here. All right then, so we're going to be moving to the next part of the measurement question then. And then this requires here, it says that liquid was poured into a container that is in the shape of the cuboid. We have to determine the height of the water or the liquid that was poured. All right. Now we're going to assume that water, even though it's a fuel tank, we're going to assume that fuel or water or some substance was poured from the cylindrical and conical covering container into the shape that we are seeing here on screen. So let's make an assumption. Let's just assume that maybe there is a, say here, a pipe that is attached here. And then the pipe, let's just make an assumption. Let's just visualize that the pipe then runs and shoots off the water or the fuel or whatever it is into here, into this particular prism here. All All right, that's the assumption that we have to make. This is how you have to intuitively visualize the math question. So assuming that everything that can possibly hold into the conical covering cylindrical container was then poured into this cylindrical tank that contains a length of 45, a width of 27, and a height that is unknown. They say, or the question requested us to find the height of the water or the height of the liquid in the tank. So the assumption here is that, of course, since we're talking about the volume, we're looking at the fact that volume again must be equal to area times height. And the area of a cuboid is length times, well, the area of a rectangle, which is the cross section of a cuboid, is length times width times height. And assuming that the volume of liquid or the volume of fluid or the volume of water or the maximum capacity of the cylindrical container with the conical covering was all poured into the cylindrical tank, then it's safe to say then that the complete volume of 7,389.99, 7,389.99 is the volume 7,389.99. That's the amount of water that could be poured into the tank, is equal to the length, which is 45, and the width, which is 27. And we're obviously looking for the height of whatever is poured into the tank. So we're looking for the height. So 45 multiplied by 27, I believe, is 1,215. 145 multiplied by 27, 1,215. So that's 7,389.99 is equal to 1,215 multiplied by h. So to find h, which is going to be the height of the maximum capacity of what was poured into the cuboid, that's going to be 7,389.99 divided by 1,215. That's equal to h. This paper is definitely a challenge, and it's a paper that requires you to think. Maybe, just maybe, it is safe to say that maybe I might have set the question a little bit above average. Maybe a little bit too challenging for my students. But then again, it's complete preparation for CSEC. We want to be completely prepared, completely rounded, and completely exposed. So then, 7,389.99 divided by 1,215, that gives us a height here of 6.08. So whatever amount of liquid, if 7,389.99 cubic centimeters of liquid was poured into that tank, then the height of whatever that liquid is would have reached a height of 6.08 centimeters. All right. I am not sure of the maximum capacity of the cuboid, so it's not safe. It is just safe to say that this would just be the height of the liquid poured into the cuboid. All right. Definitely a tough question, guys. Definitely a tough one, but at least then you now know how it is that you have to think through a problem like this. All right. Right. Good. All right. So if you completely grasp that concept, then by all means, then be sure to hit the like button and leave your thoughts and comments below. And if you are in any way a little bit confused about what was explained, keep watching that section of the video again and again and again until you get it. All right. We have a few more steps here. We have another measurement question, which is in the area of, which is in the department of area, and then we have this final question here. For question 5, then it says that the diagram below represents a floor plan of the section of a house with the shown dimensions. So I'm going to pull up that question on screen here for you, and that is the diagram of the floor plan. Let's make some observation here. What we're looking at here then, in fact, is that we have a side here that is 12.5. We have another side here that is 17.4. another side here that is 4.7. We have a missing side that is labeled B, a missing side that is labeled A, another side that is 3.2. We have two small shapes inside with a width of 2.1, and we have a length of 6.6. We also have a circular hole here with a radius of 2.3 centimeters. And those are the information that's given to us. Let's then look at the fact that they ask us to find the length of the sides marked A and B. So the length of the sides marked A and B can easily be determined by some logical thinking. So for A here, we notice that A is parallel to the 12.5. And since A is parallel to the 12.5 and 4.7 is also parallel to the 12.5, a part of the 12.5 is already marked out to be 4.7. So I can easily calculate A here by subtracting 4.7 from 12.5. And you'll find here that the answer is 7.8 centimeters. So this part here is in fact going to be 7.8. It's a similar thought process with B here, where B is parallel to 17.4 and 3.2 is parallel to 17.4. So it is safe to say that a part of the 17.4 is 3.2. So to calculate B, B can easily be calculated by subtracting, say here, 3.2 from 17.4. And you're going to find here that the answer is 14.2 centimeter. All right, that would have given you 1 mark each. Let's go ahead and put that information on our diagram. Beautiful. So then the next part of the question then asks us here to calculate we are to determine the perimeter and the area of the floor. So there's 2 parts to this here, assuming that 2 marks for the perimeter and perhaps 3 marks for the area, give or take. So I think this is about a 5 marks question. Let's look at the perimeter of the floor, then we look at the area of the floor. So the perimeter of the floor is simply going to be adding up all the sides that we now have. So the perimeter, P, is then equal to, let's start with the 4.7 at the bottom. Let's move towards the left. 17.4. Move go up to the top, that's 12.5. Move along to the side, 3.2, plus the sides that we calculated, 7.8 and 14.2. And then of course, that would be the final length there. So mathematically, when I calculated this, I got 59.8, but let me just verify again, 4.7 plus 17.4 plus 12.5. It's always good to double check, guys. 3.2 plus 7.8 plus 14.2. And of course, I got the correct answer of 59.8 centimeters. All right, nothing's wrong with rechecking. They also ask us to calculate the area of the floor. So please note that the area of the floor includes the holes that was here, okay? The rectangular hole and the circular hole. So therefore, we needed to calculate the floor itself. So we have to ignore the rectangle and the circle, okay? Just the floor itself. There. So therefore, to do that, then we will pretty much have to cut this composite shape here, or this merged composite shape, into parts. So if I were to draw a line from here to here, we would end up with two separate rectangles. I'm going to call this, say here, rect A, and I'm going to call this down here, say, rect B. I'm going to find the area of rect A, and I'm going to find the area of rect B, and I'm going to add them together. So the area of the floor is then going to be equal to the area of rect A plus the area of rect B. So both shapes are rectangles, so they would have the same formula with the exception of different measurements. So area of rect A equals length times width. So let's look at rect A. Rect A has a length of 12.5 and a width of 3.2. So 12.5 and 3.2. That gives us an area there of 40 square centimeters. And then of course, area of rect B let's just go up here, keep it on one page. Area of rect B is equal then to length times width. So rect B then is going to be 14.2 multiplied by 4.7. 14.2 multiplied by 4.7. That's 66.74. And so we can conclude then that the area of the floor is going to be the area of rect A, which is 40, plus the area of rect B is 66.74. So this then works out to be 106.74 square centimeters. Okay? And that is the area of the entire floor. So that takes care of that particular question then. The perimeter and area of the floor. It says then determine the area of the shaded portion. Upon starting this video, I had erased the shaded section, but what we were looking at then is in fact, say here, the shaded portion was in fact, let me see here. The shaded portion was in fact in this section here, around. So it's going to be excluding the circle and the rectangle. So I would have just accidentally erased that. So therefore, we already have the area of the floor. So the only thing required here is for us to find the area of the rectangle, the small rectangle inside. Let's just use a different color for that. So we can find the area of this rectangle here. And then we can find the area of this circle and subtract both of them from the area of the floor. Or we could add both of them and subtract it from the area of the floor. That would literally give us the area of the shaded portion. My students would know that the method for doing this is subtracting the inside from the outside. So there's two different shapes. I was really testing my students' ability to remember the basic formula along with applying the concept with these types of questions. So then what we're looking at then is in fact the area of the small rectangle inside. So area of small rec is equal to length times width, which we looked at to be 2.1. Well, it's 6.6 multiplied by 2.1. In a moment, I'll get the answer for that. And then, of course, the area of the small circle, or the only circle, the area of the circle, is in fact equal to pi r squared, which is going to be 3.142 times 2.3 squared. So when we match this up, we end up with 6.6 multiplied by 2.1, we get 13.86. And of course, 2.3 squared multiplied by 3.142 gives us an answer of 16.62. That's it, squared centimeters. So if we want, we could just add both of them together. That will give us the area of the section of the floor that was cut out. So that's area of both shapes is equal to 13.86 plus 16.62, and that's equal to 30.48. And so the area of the floor, if we go back to what we had established around here, that the area, let's go back here, we had established that the area of the shaded portion, okay, we didn't write it down. Let's write it down now. So we are now establishing that the area of the shaded portion is equal to the area of the floor minus the area of both shapes, small shapes, the rectangle and the circle. So the area of the floor was calculated. If we go back to our calculation here, the area of the floor was 106. The area of the floor was 106.7. And we're going to subtract the area of the two shapes together, which is 30.48. So we'd have gotten an answer here of 76.22. Let's verify. I think I may have made a mistake with the area of the floor. Let's see if I had it correctly here. Area of the floor 106.74. Okay, 0.74. Let's be a little bit more accurate. So 0.74. So let's do that again. 106.74 take away 30.48. 76.26 as opposed to 76.22 square centimeters. So that is the area of the shaded portion in orange here. All right. Fantastic. I feel like this is a really good comprehensive review of what we have learned and total application of all the concepts. Really good video. We have about 7 minutes to be on the 2 hours. I think this is a really nice video, a really comprehensive review, that is. All right, and let's just go to the last question here. That brings us to the end of that area of shaded portion. Now the last question here is that it is for a different group of students. It says here that a dining room set has a cash price of 38,500 and is now on sale for 27,300. We are then asked to determine the discount percentage that was offered on the dining set. Well, to find the discount percentage, we would definitely have to calculate how much discount was given. And then to express it as a percentage, we have to make a comparison with what was initially its cost or its cash price. So let's go across here and we can check here that discount offered was in fact 38,500 minus the $27,300, 27,300, 38,500 minus 27,300. It would mean that the customer currently is getting an $11,200 discount. So this 11,200 must be expressed as a percentage of its cash price. Most percentage are expressed in terms of its original cost or its cash price or cost price. So as a percentage, you have to times it by 100. So 11,200 divided by 38,500 multiplied by 100. This is now discussing here that a 29% discount was offered, right? So that is how you would have attacked that question there. It then proceeded then to ask us to calculate then. It says that they are also offering a higher purchase deal where a deposit of 13.5% must be put down and the balance to be paid in equal monthly installments over a period of 2.25 years. Now, provided that 24% interest rate was charged on the outstanding balance, some of the questions were cut off. We are supposed to calculate the amount of money per monthly installment. So let's get to it then. So what we're looking at then is in fact making a down payment on the item. And so for example here, 13.5%, so that's 13.5% over 100 multiplied by the original cost of 38,500 will be my down payment. So 13.5 divided by 100 multiplied by 38,500. It would mean that I would need to put down a total of $5,197.50 to get started or to get the item. Now, once I put that down, then it means then that I would have owed an outstanding balance of 38,500 minus 5,197.50. So that's 38,500 minus 5,197.50. I would have owed the company now 33,302.50. That's what I would have owed. Now, it did say here that an interest of 24% was charged, interest rate. So I'll then need to find 24%, so that's 124% over 100 multiplied by 33,302.50. Some students would have found 24% of 33,302.50 and then add it back to 33,302.50. I think that a shorter method here would just be to just add the 24% to the original cost, which is 100%. So this then works out to be 124 divided by 100 multiplied by 33,302.50. So the total owing at the moment, including the interest charge, is 41,295.10 cents. 295.10. Let me know in the comments if when you worked out 24% over 100 times 33,302.50 and you add it back to the total, if you got the same value as I did. Let me know in the comments. But I felt like this is a much smarter and more efficient way of getting to the answer. So this is the amount that is currently owing, including the interest that was charged. Therefore, then, if you're looking for the amount of money per installment, we know that this is a deal that would have been acquired for, it says here, 2.25 years. So 2.25 years. Now, hire purchase is a monthly agreement, so we need to convert 2.25 years to months. Well, 12 months make a year, 24 months make 2 years, and 1/4 of a year is in fact going to be 27 months. So this is in fact 27 months, all right? So therefore then, we're going to be dividing what is owing by how long it will be owed for. And so we are going to be making a down payment monthly of $1,529.45. All right. And that is the calculation required for that particular problem. Might I say it was a challenging problem? I don't think it was. It really just requires you to understand the concept of what needed to be done, the solve process. All right. We have reached the 2-hour mark, and that has also brought us to the end of this particular term exam. I do find that this particular exam was a comprehensive review. Let me know your thoughts and comments down below, and use this as an opportunity to prepare for that end of term exam, which is going to be quite an interesting exam. Hopefully it's a lot easier on the measurement side than it was. I do believe that the measurement here was a challenging question, but it's one that I would hope equipped you for the future. And if you can find yourself understanding this type of question or this level of question, then you're mentally preparing yourself and building yourself for any challenge that will face you in the near future. All right. So thank you guys so much for staying tuned for the whole entire tutorial video. And until next time, my name is Apex, your math instructor. Continue practicing and becoming consistent and a more efficient math student. Please like, share, and subscribe. And of course, leave your thoughts and opinions. Check the description box below. You'll find useful tips and also information to how you can join my comprehensive and exclusive CSEC preparation class for the 2023-2024 exam. So until next time, take care and keep on practicing. Bye bye, guys.